All right, welcome. Today, we're going to demystify one of the most powerful and, let's be honest, potentially dangerous tools in Assisted Min's toolkit, LVM thin provisioning. We're basically turning a set of real-world DevOps notes into a clear step-by-step guide so you can really get a handle on this incredible storage technique. So here's what we've got on tap. We'll kick things off with the basics. What even is thin provisioning? Then, we'll get our hands dirty and build a thin pool from scratch. From there, we'll get into the fun stuff, the magic of overcommitted volumes, face the very real dangers of running out of space, and then wrap it all up with the best practices to keep you safe.
Okay, first things first, to really get why this is such a game changer, we need to talk about the problem it's designed to solve. And trust me, it's a headache anyone who's ever managed storage knows all too well. Right. Have you ever set up, say, a 100 gigabyte disk for a new server, only to check back a year later and see it's only using like 10 gigs? That's 90 gigabytes of your pricey, fast storage just sitting there, doing absolutely nothing. That exact wastefulness is what thin provisioning is here to fix. And here is the brilliant solution. Instead of carving out all that storage up front, thin provisioning is all about being just in time. You create this shared pool of storage, and it only hands out physical blocks to a volume at the very moment data is actually written. This means we can promise way more storage than we physically have, and that's a super powerful concept called overcommitment. This little table just lays it all out perfectly. You know, with the old school thick provisioning, if you ask for a terabyte volume, you have to sit there and wait for a full terabyte of blocks to get reserved. It's slow and so often a total waste of space. But with thin provisioning, that same volume is created in a flash because all you're doing is making a tiny little note in the metadata. No actual data blocks have moved yet. I love this analogy because it just clicks. Think of it exactly like a credit card. The bank gives you a really high credit limit, that's your virtual size, but you can only actually spend what the bank has in its vault. That's the real physical pool size. As long as the bank has cash on hand, everything's great. But if everyone tries to max out their cards at the same time, well, that's the danger we're going to talk about in a bit. Okay, enough with the theory. Let's get our hands dirty and actually build one of these things. We're going to walk through the exact commands step by step to go from a blank disk partition to a fully functional thin pool. All right, we're going to follow these 4 fundamental steps. First, we just need to partition our disk using a standard tool like fdisk. Easy enough. Then, we use pvcreate to tell LVM, hey, this piece of disk is available for you to use. Next, we bundle that into a volume group, which is basically just a container for our storage. And finally, the moment we've been waiting for, we create the thin pool itself right inside that group. Now hang on, you might have spotted that little S32M flag in the last step and wondered what that's all about. Well, this is a fantastic pro tip. This sets something called the extent size, which is the smallest chunk of space LVM deals with. By making it bigger, say 32 megabytes, LVM has way less metadata to keep track of, which makes really, really large pools a lot more efficient. It's a small tweak with a big impact. Okay, our pool is built and ready to go. Now for the really cool part, where the magic happens. We're going to create some logical volumes that, when you add them up, are the same size as our entire pool. This is where you'll see the power of this on-demand allocation.
Okay, let's just lock this number in our heads. 15 gigabytes. That is the actual physical amount of space we have to play with. This is our ground truth. And now watch this. We're going to ask for 3 separate volumes, each one claiming to be 5 gigs. The most important part of this command is that V flag. It stands for virtual size. So we're not asking for 5 gigs of real hard disk space right now. We're just asking for a promise of that space for each volume.
And would you look at that? The system reports that we virtually allocated 15 gigabytes. That's our 3 5-gig volumes. But look at the actual physical usage. It's 0. Or, something very, very close to it. We just created 15 gigs of storage in less than a second without actually using any real space. How cool is that? Of course, a volume isn't much use if it's empty, so let's simulate some actual work. We're going to use the fallocate command. It's perfect for this, to instantly create a 1 gigabyte file on each of our 3 volumes. This is the action that will actually trigger the pool to start handing out real blocks. And there you have it. Look at what happened. Our virtual allocation is still sitting at 15 gigs, right? But the actual usage bar has now jumped up to 3 gigabytes, 1 gig for each of those files we just created. The pool only gave out real space when it was absolutely needed. This right here is thin provisioning in action. Now, all this incredible power and efficiency, it comes with a pretty sharp edge. Overcommitting storage feels like you're getting away with something. But if you're not paying close attention, that magic can disappear in a puff of smoke. Let's talk about what happens when the pool runs dry. This is the error message that should give any sysadmin nightmares. When your thin pool runs out of real physical blocks, every single attempt to write new data to any volume in that pool will fail. Hard. The scary part is the operating system inside a VM might be happily reporting that it has tons of free space, but the storage underneath is just saying, nope, and everything just stops. So, how do we dodge this bullet? The key is being proactive, not reactive. It's really a simple three-step dance. 1. You have to monitor your pool's data usage like a hawk. 2. When it starts getting full, you add more physical storage to the volume group. And 3, you tell the thin pool it's allowed to grow into that new space. The trick is, you have to do this before it becomes an emergency. And to make things a little easier, here are all those key commands in one place. We've got creating the pool, creating a volume, extending the pool, and, most importantly, monitoring it. Go ahead and screenshot this one. It's a perfect little cheat sheet to keep handy. Okay, we've seen the power, we've seen the danger. So how do we use this tool like a pro without causing a disaster? Well, it really just comes down to being disciplined and sticking to a few golden rules. These 3 rules, they're basically non-negotiable if you're using this in a production environment. First, don't get greedy with overcommitment. A good rule of thumb is to keep your total virtual size to no more than double your physical pool size. Second, monitoring is not optional. You need to set up alerts to warn you when you hit, say, 80% capacity. And third, and this is the big one, you have to act on those alerts. Extend the pool when you still have a comfy buffer, not when everything is on fire.
And once you're comfortable with the basics, there's even more cool stuff you can do. We already talked about using larger extents. But thin provisioning also makes for amazingly efficient snapshots. Since a snapshot only has to record the changes from the original, you can create backups or test points instantly without having to copy all the data. And for the really advanced setups, you can even configure LVM to auto-extend pools when they hit a certain limit. Look, if you only remember one thing from all of this, let it be this right here. Thin provisioning is not a set it and forget it kind of deal. You have to treat it like a shared resource, like the water in a town well. You have to plan for growth, keep an eye on the water level, and add more capacity long before it runs dry. That proactive mindset is everything. So we've gone from start to finish, from creating a pool, to managing it, to avoiding disaster. You now have a solid foundation to use this technology safely. So the next logical question is, what about automation? What kind of scripts could you write to monitor and alert you? Could you build a tool to automatically extend the pool when needed? That's your next adventure. Thanks for joining me.